Hey, mathematicians, this is Mrs. Shopper coming with our last section for 8. This is dealing with vectors. Think of, oh shoot, why can't I think of the name of it? Despicable Me, right? And Vector, his name is Vector, right? All right, Vector describes both magnitude and direction, right? So Vector gives you magnitude and it gives you direction. And so magnitude is actually just a fancy word for length. Hint, you're going to use the distance formula. Oh gosh, it came back again from last year. All right, distance formula, make sure you've got that. And then direction tells you, it's 2 different ways that you can do it, and we'll talk about it. The direction can either be the angle that it forms with the horizontal axis, so with the horizontal axis, or as a measurement between 0 and 90, either east or west of north or south. We're going to explain them. You're going to get them. All right. But vector means both magnitude and direction. Okay, here we go. So vector addition, you know what? We're not going to do a lot with this. We're not going to do a lot with this. When you're adding your vectors together, you're adding basically how far you go with one, how far you go with the other, and from there. It's really, we're going to talk about it, but it's not a whole lot you need to worry about. All right, so we're going to skip that one. All right, so standard form. Standard form is the initial point to the terminal point, okay? The initial point is where it begins. The terminal point is where it's going to end. That's the standard form, all right? Now, component form, this is new. So by the way, the terminal point is just the ordered pair of where it ends up. The component form is a little bit different. All right, it's written with, look at these fancy things. Look at these fancy component symbols, right? They're not parentheses. I need you to know that they're not parentheses. They're like angled, okay? And that really tells you, honestly, look at what this looks like. It looks kind of like the slope formula. What's the change in the x? What's the change in the y? Going from the original to the terminal, terminal meaning end, where does that fall? So we're going to practice this. So these you do want to get down into your notes. So if we're going to write the component form, all right, so component form tells me that I have to use these symbols. That's component form, all right? Now what I do is I ask myself, how far am I, what am I doing with the x? I'm going backwards 3, so I'm changing my x by -3. 1, 2, 3, oh, 4 it looks like. 4. And then I'm changing my y by 3. So this component form says no matter where you start, you're going to go back 4 and you're going to go up 3. That's what component form tells you. All right, so the component form of A and B, again, component form means I want to use these fancy angled sides. And I'm going to say, how far does my x get affected? It goes to the right 2, so that's +2. And it goes up 1, 2, 3, 4. It goes up 4. All right, 2, 4. Whew, that's component form. It's just talking about how it's moving. That's how it's moving. Now, if you want to find the magnitude and direction of the vector, so this is the vector. It starts at one point, it ends at another. That's your vector. And with your vector, you can know magnitude and direction, right? Magnitude and direction. I've been sitting here recording a few too many videos. I'm getting antsy. All right, here we go. So the magnitude is simply the length. Okay, so so how do I find the magnitude? Well, it tells me 2, 4 is the vector. So it tells me I'm going to go over 2 and I'm going to go up 4. So this is my vector. Now, When I'm trying to find my magnitude, so it's going to be distance is equal to the square root of, and if it starts at 0, 0, it ends at 2, 4, at the distance of x sub 2 minus x sub 1 squared minus, or plus y sub 2 minus y sub 1 squared. So the distance is equal to the square root of 4 plus 16, which is 20. So the distance is going to be 2 square roots of 5. And we've done the square root of 20 a few times in our notes. That's how I was able to do that. Okay, so that's my distance, simplest radical form. Now direction, here's where trig functions come in, and this is why we're talking about vectors right now. My direction can be one of two ways. It can either be degrees from the horizontal, so that means how many degrees is it from wherever it's at, and it goes counterclockwise, or how many degrees from the north and south line. So either way I do it, I have to find the degrees. I need to know either this angle or I need to know this angle, either way. So in order to find it, I have to use trig functions, right? So when I look at this, let me get my picture drawn again. Emma, is she here? There we go. So it was here, like this, right? So I can draw myself a right triangle. And I can find my measurement because I know that this is over 2 and this is up 4. I know that it's a right angle. So I can use opposite over adjacent tangent. So I can say that the tangent, the inverse tangent of opposite over adjacent is equal to that angle measurement. So the inverse tangent of 2 is going to be, measurement of the angle is going to be 63.43. That's this angle right there. So here's the two ways that we can write it out. We can say it's either 63 plus 0.43 from the horizontal, because that's how many degrees up this is, or this angle is going to be 26.57, right? Because together they equal 90. Then I could say the other option is 26.57 degrees east of north, because I'm showing it's east of the north part of the line, east of the north point. So either one of these will work for me. Honestly, I don't care. If you write them both and one is wrong, then you get the problem wrong. So make sure you really understand one of them. And then here is my distance. Okay. If we want to find the magnitude and direction of one that is 4, -4, that means we start here. We go 1, 2, 3, 4, 1, 2, 3. I put my dot. This is what I'm talking about. All right. So my magnitude is my distance. The distance, if it's going from 0, 0 to 4, 4, is 4 squared plus 4 squared. And then the distance is equal to the square root of 32, because 16 plus 16 is 32. So then D is equal to 4 square roots of 2. How did I get that? The square root of 32 can be broken up into the square root of 16 and the square root of 2. The square root of 16 is 4. Square root of 2 is 2. That's how I got it. So there's my direction. Now to figure out my degrees, all right, I want to create my triangle and figure out right here. All right, 4 and 4. So I'm going to use the inverse tangent of 4 over 4, which is 1, I guess. So it's a 45, 45, 90 triangle equals the measurement. So the inverse tangent of 45 nope, wrong. The inverse tangent of 1 is going to give me 45 degrees. So how I can write it is it's 90, 180, 270, 315 from the horizontal or 45 east of south. Either way is fine with me. All right, we're going to jump to vector operations. So, because the video is getting long again, I think. So here we go. So if x, I'm going to add x and y together. So x is -1, 4, and y is 3, 1. If I'm going to add those two together, -1 plus 3 is 2, 4 plus 1 is 5, and there it is. All right, you're literally adding your x's, adding your y's. For b, we've got -2, -4, minus -1, 4. So -2 minus -1 is -1. -4 minus 4 is 0. That's the component form. You're adding your x's, you're adding your y's, or in this case, subtracting. And for c, what we're going to do is we're going to take double 3, 1. And then we're going to add -2, -4. Sorry, I'm running out of room. So I've got 2 times 3 is 6, plus -2 is 4. 2 times 1 is 2, minus 4 is -2. And here you go. There you go. All right. See you soon. That's it for chapter 7 or 8. 8. All right. I'm out of here. Peace out.